Okay, now this is might look similar to what we did yesterday on 15.1, but 15.2, one difference there. Also, you'll notice as this is increasing, it's not increasing by 8 here, but then 40. So it's not increasing by a constant amount. It's increasing by an increasing amount, which means it's not arithmetic at all. It's geometric. And upon further review, instead of adding something, we're actually, if you multiply by 5, and multiply by 5, multiply by 5, we have a geometric sequence. And so the sigma notation thing remains the same. We need to get an equation here. This is the first term of a sequence, and then the second and third and fourth. So if we say n equals 1 to 4, that's going to represent the first 4 terms. However, if we recognize it's multiplying by 5, and so on and all that kind of stuff, then we have to go back one to get to our 0 term. Okay, so our equation, if we're going to look at our 0 term, we got to go back one to 2 over 5. And so 2 divided by 5 is going to be the one prior to the 2. Okay, and so then we multiply by 5, it becomes 2, multiply by 5, it becomes 10, and so on. So 2 over 5 is our initial value, times 5 to the n power. And that n, as we plug in the n, to the first power, we multiply, we get the 2. When you square it, raise it to the second power, you get 25, but that turns it back into a 5, reducing the 5s, and then the 5 times 2 would give you the 10, and so on. So the sum of the series, it's easier probably just to, you don't have that pattern we had yesterday where this is going to add up to the same thing as that. We have 250 plus 50 is 300, 310, 11, 12. So 312 for the sum of the series.